Maybe you didn't go last Saturday, so you're still eligible for the extra credit. That's nice. But either way, whether or not you get extra credit, you can still get community service hours. You can still get hours toward the Student Environmentalist Award. And obviously, you can still do something to help improve local environmental conditions and be a part of your community. So if you'd like, this Saturday morning, it should already be on the Green Club Facebook group page. And if you don't remember, our Green Club group page is here. Second, there's a film festival Saturday night, 5:30 to 9:30, at the Marjorie Loop Theater called the Wild and Scenic Film Festival. Anybody here heard of the Banff Mountain Film Festival? The Wild and Scenic is very similar. It's a mix of environmental documentaries and wilderness adventure documentaries. So they usually have like some dudes base jumping, or some people climbing rocks, or some people running rapids in a little flatboat. And then they'll mix that up with some stuff about wolves or about eagles. The show this Saturday has, here, I can even tell you exactly what movies they're showing. This Saturday, they're showing, oh, my internet connection is so slow, sorry. Here we go. This Saturday, they are showing, oh, they even have trailers. A movie called How the Kids Saved the Parks, about a student-led effort to preserve parks, California state parks. There's a movie presented by Patagonia. Sorry, I don't feel like yelling. Is these questions for me? Do you want to talk? 'Cause I'm down.
We were talking about the Green Club stuff.
Can I help? Yes?
Wait, what? Is it another beach cleanup?
I don't know. It's on the Facebook group. I'm sorry, I don't remember. Is it on there now? Sorry, Daniel will have to put it up soon. I'll let you know by tomorrow. I'll reach him today.
Thank you.
It's some sort of a service project. I don't know if it's a cleanup or something different. Sorry about that. Yeah.
Is this one going to be like early in the morning too?
Yes, it's a morning one. I don't know how early. At the film festival Saturday night, there's a movie presented by Patagonia called Last Light about people who photograph alpenglow, which is that weird sideways light you get like right at the moment of sunset when everything looks all red and orange. There's a movie about not drilling. It's made by the Sierra Club. It's called Too Special to Drill, and it's about not drilling in our national parks or national forests for natural gas extraction. There's a movie based in our Channel Islands about the bald eagles coming back. There's a movie about a guy who lived on a bike for 382 days.
Whoa.
Yeah, there's a movie about bringing bison out of Yellowstone National Park to a Indian reservation. There's a movie called The Water Tower, which is about a rock climber named Pete McBride, kind of a famous climbing guy. There's a movie about getting low-income senior citizens into Yosemite National Park and like what they do when they're out there. It's supposedly really quirky and funny. And the last movie is a really famous one that's won a bunch of awards already, called Wild Things, about basically about the predator effect, about how our National Park and National Forest Service exterminate predators as a long-lasting practice. But in many parts of the world, we realize predators are really important, so your tax dollars are paying to exterminate predators. The movie says, hey, maybe we should reconsider that. These are all short films, all on Saturday night. It goes from 5:30 to 9:30, and the first hour is like I don't know what they call that, like a vendor venue. So they'll like show you like, hey, I make these special water bottles or whatever. But they have some giveaways and like meet and greet and food and drinks. And then starting at 6:30, they show, I think it's 9 movies from 6:30 to 9:30. And you get 2 points for that one just for attending. It does cost money though. Yeah.
Oh, where is it?
It's at the Marjorie Luke Theater, and you buy tickets on the LPFW website. It's called Los Padres Forest Watch. So it's a fundraiser for our local national forests. I very strongly recommend that one. There will be a sign-in, like with the last movie. You just show up, and if you're there until the end, then it's 2 points for showing up. Questions about that one?
Wait, so do you go to one movie or do you stay the whole time?
It's a 3-hour film festival with a 1-hour intro period, and you got to stay for at least the 3 hours of the movies.
Yeah.
And you would presumably see all of them in that time period. Yeah.
Is there a write-up for that, or do they just give you a ticket?
Neither. You just sign in and sign out.
Oh, okay.
Anybody else?
How many points is that?
Community events are usually 2. Community service stuff is usually 4. So those are both this weekend, yes?
Can you go to community events as many times as you want and still get extra credit?
I've never set a limit so far. I think at some point, if it gets really ridiculous, I wouldn't, I've always thought that you should not be able to do like a whole exam's worth of extra credit. Like you still need to have legitimate exams. But until we get to a real, like pushing the limit of the extra credit, I won't stop that.
And what night is that?
They're both on Saturday. One in the morning, one in the evening on Saturday. Yesterday, I gave you your Unit 1 packet, and a lot of kids asked me, like, do I keep this? Do I recycle it? Remember, it's on the first page of your policy procedure packet, and it's on the wall. You keep all your papers all year. It's for points at the end of the school year. Don't say I didn't warn you. At the end of the year, I tell my students, okay, now bring in all your packets for your 5 points. And there will be some kid that goes, I didn't know we're supposed to keep our paperwork. And then we'll all throw rocks at them. I've decided to throw out number 6. So if you remember how you did on number 6, then you can recalculate your grades based on 14 if possible. Yes?
So, if you got number 6 right, is that...
So if you had 15 out of 15, you now have 14 out of 14.
Okay.
It's thrown out either way. Some kids' grades will go down because that was one of the ones they got right and that was helping them. But that's by far the minority. I had to pick this not based on how it impacts your grade, but on the fundamentals of the question.
Okay.
And whether it helped you or not, it wasn't a good question. I feel that the kids that it might have helped because of a misunderstanding or a guess, not necessarily because the question highlights their knowledge.
So is the curve still at 32? Or is that 31?
It depends if it changes the grade of the students who set the curve. So the curve might change. If it did change, it would only drop presumably by 1. Okay, this is the part where I want to give you the stars for the study guide. You'll want to take that out. And then you'll probably want all your homework out too, because we're going to get ready for the exam after that. Oh wow, during that first hour, there's a raffle for a gift certificate at Sojourner, Island Seed and Feed, a Camelback backpack, shoes from Deckers, some like gift soap cologne stuff, and a couple of jackets by Patagonia. Hey Jack, do you know how to reach Daniel Feinberg? Chris, do you know how to reach Daniel Feinberg? Jack, you have web access on that telephone? Go to Facebook, search for this group, join that group, it's open, and then send a message to Dan Feinberg, who's another member of that group,
This,
That says Jose needs the information on the page yesterday for the Saturday event. Any way you want, however it works. Yes.
are you good friends with Dan?
Well, I like to think I'm good friends with all my students. What do you mean? Like,
Oh, it's just,
right.
sorry.
It's a student. And Dan is, yeah, I mean, he's a really good kid and everything. I mean, I don't really play favorites too hard. But is that another question you meant to ask?
No, I think I knew one of this. I was just wondering. I thought that he was like a father or something.
Got it.
So.
Remember that the stars do not predict whether or not it goes on the exam. The stars highlight complexity or challenging details, not whether or not it goes on the exam. You remember from yesterday's exam, there was stuff on there with no stars. Yeah.
The things that we started in Unit 1 that you said like will be throughout the whole year, should we review those for the Unit 2 test?
That's a really good question. I guess if you feel like those are tricky for you, maybe, yeah. Usually, like, if we built on something from before, you'll notice. It's not like I'm going to surprise you with, like, back to Unit 1 all of a sudden. But yeah, the stuff with the stars will be part of future units. And so that's kind of why I tell you to look out for it. Like, we're going to build on this in the next few units. Watershed gets 2 stars. The plate boundaries, divergent, convergent, and transform, that gets 1 star. Upwelling gets 1 star.
Like, what was the second one?
The plate boundaries.
Number 3 gets 1 star. 5 and 6 each get 1. Look at number 7, please. The second question gets a star in number 7, meaning the amount of time that chemicals spend in each of the spheres. That's a really critical concept. To think that when something is bound in rock, that's going to be on the geologic time scale. When something is in living organisms, that's on a metabolic time scale. And when something's in the atmosphere, that's basically a real-time time scale. Number 9 gets 2 stars. And please notice that the warm-up is kind of relevant to number 9. 11 and 12 each get 1 star. 14 gets a couple of stars.
So 3?
Couple meaning 2. Couple is in a pair.
Yeah, couple. 14 too.
15 gets 2 stars. And the idea of a carbon sink at the end, that gets a star. Have we talked about carbon sinks in this section? Then maybe today we'll have time.
Is missing carbon sink also a star?
Yeah, I mean it's the same idea as the carbon sink. You can't have one without the other in the conversation, so yeah. 16 gets 3. You'll see the nitrogen cycling all the time. 17 gets 1 star. And I don't know how to tell you this. 19 is like 1,000 separate facts. I gotta tell you that on average, the AP test has a lot of trivia. So I found for you the most famous keystone species. And I either put them in my slideshow or I put them in the reading. I don't know which ones of those you got to know for the AP test. The test does have trivia. they ask about individual species. So I'm just giving you a heads up. 19 is like part of the trivia collection. You need to know a lot of trivia for this test. Imagine, they'll ask a question about the California condor on the AP test. They've done it before. Kids in California are like, I know the condor. Imagine being a kid in Kansas. What do they know about California condors? So anytime you get a chance to learn about a single species, just throw it into your trivia pool. You know, like Trivial Pursuit, you can't study for Trivial Pursuit. You either know trivia or you don't. The test is a little bit of Trivial Pursuit. You just got to know, like, they'll ask you a question about the kangaroo rat. And either you know that they regulate diversity by stashing seeds, or you didn't know that. Just trivia. Okay. Any questions about the stars? Please look up. I have some general pointers. You saw yesterday that detailed study goal notes answer all the questions on the test. Let me remind you again. You don't do your homework for me. You're not convincing me of anything. I don't need your homework. I don't like homework. You do the homework because the answers you've written are the test answers. I made sure of it. When I write the test, that stuff was somewhere in the study guide. But I'll give you a heads up. This is a more detailed unit, so it becomes increasingly about the details. Yeah.
Does that say detailed 5.6?
No, that says SG notes, study guide notes. Next, don't forget that rule of 70. There's population growth questions everywhere. I'll give you a hint right now. There is a rule of 70 question on the exam. I'd like to make a suggestion for you. When you write your essays, start thinking about talking to a 2-year-old. You know how 2-year-olds keep asking you why? So you say the sky is blue, and they say why? And you say, well, because of the water molecules. And they say why? And you go, well, because the bond distance from 420 nanometers blue. And they go, why? And it's like, just I don't know anymore. Stop it. Like, you want to give all those sort of details as if a 2-year-old was asking you why. Don't put a period if you could put a comma because detail. Remember that the College Board, you saw the key. The College Board doesn't give you any points for the general part. The general part that you get by watching CNN, that's not going to give you a good grade. You don't need generalities. You need the details. So remember the 2-year-old rule. You got to keep giving the details until you don't know the details. Yeah?
Yesterday, you showed us a test that was like the different justifications, and you said it has to be full sentences, but it was like utilitarian, colon, and then it said what it was.
Yeah, I noticed that too. I asked my TAs, and they said no, that they actually had a full sentence that identified it. That would not be okay to have a colon like that.
Yeah.
So if the sentence didn't actually, a complete sentence, that colon didn't count. That wasn't a part of the answer. And that's a really good question. Remember that. You may never answer with outline form unless it's a full sentence. I want to encourage you guys, invest your time differently. Just think about it more and spend less time writing. Outline your answer, like scribble details, and then 2-year-old detail, why detail, and then just write a single sentence that really captures the details. You should really think more and write less. It's not that there's anything wrong with your writing, it's just that you're wasting your time. You saw the answer key. They're just looking for a single sentence that addresses each single action word of the question. The homework packet should be packetized. You need the food webbing post lab, the 2.1 through 2.4, and the Unit 2 warm-ups. If you did any extra credit, that comes in tomorrow too.
You said that earlier in the year, you said if we find any like articles and magazines or anything that relate to something that we're in the unit or environmental science, to include those or give them to you?
Yeah, but not in paper form. You submit them to me electronically. And honestly, I haven't set that up in EDU 2.0 yet.
So we shouldn't, if we find something, we shouldn't staple it.
You don't need to staple it to this. In this unit, I want to make sure that everybody has equal access to the extra credit, so I won't accept that yet. But you should definitely remind me, and we'll get going with that for Unit 3.
Okay.
Okay, now comes the part where I'm available to help you answer any of our missed study goals. Did we already talk about nitrogen cycle, 16, 17, phosphorus cycle, number 18?
I don't think we really did 17.
The good news is number 16 answers all the questions of number 17. So look, you ask me a question in 17 and I'll show you that you already know the answer. Who would like to ask me the questions one at a time? Great, go.
Does the next molecular nitrogen enter the cycle through nitrogen fixation? Okay.
So look, you already know all of these. Please ask me the question so I can show everybody that you know it. Question number 1 is,
How does it enter the cycle?
how does it enter the cycle? Right here, look. Because we already talked about that. It makes it usable. That's what fixation means. What's the next question?
What are other sources of ammonium?
Well, there's fixation and decomposition. Ask me another question.
How is nitrogen used by living things?
I think you know that. Proteins, amino acids.
Does it? How does it get back into the atmosphere through denitrification? Okay.
And it's not dentrification. That's to make something in toothpaste. Okay. I got you, bro. What is it?
Does nitrification go back to the atmosphere?
No, it's the second step. Nitrate can be a gas, but in the soil it's usually dissolved in water. I think nitrate, I hope I don't know. But the gas stage is this one.
Decomposition and nitrification. So does nitrification have to happen before denitrification?
Yeah, that's right. Because each of these steps makes a single transformation. So there's one type of bacteria that lives in an aerobic environment that adds on the oxygen. And then there's a separate type of bacteria that lives in an anaerobic environment that rips off the oxygen. Yeah?
Sorry, so you said nitrogen is used for living things because of amino acids. Like,
Yes.
amino acids are made of nitrogen?
Yes.
Okay.
Well, there's a lot of nitrogen in amino acids,
Okay.
and all amino acids require nitrogen. But there needs to be an amino, I think. Yes?
Number 18 is what role does phosphorus play in nitrogen?
Oh, yeah.
And how does it get oxygen?
So these are two important things. I want to weed apart the two separate questions of 18. So remember, we're doing number 18, and it had two separate parts. Jesse says, first question, what role does it play in terrestrial ecosystems? Anybody remember that for number 9? Phosphorus is used how from number 9?
ATP and ADP.
That's right. They are energy storage compounds in living things, ADP and ATP. Everybody remember that? And then, what was the other question, Jesse? Sorry.
How does it get off
How does it get onto
the land?
land? Well, there are two possible ways. And this is half the answer to your warm-up. Remember, one possible way is we take it out of biomass. All of your bodies have phosphorus. If I take Alessio and throw his carcass over the fence, phosphates in his body would just come out in the juice, and that would be plant fertilizer. We can decompose down to phosphates. So it comes out of biomass, like biological cycling. So whether you eat a plant and get phosphorus, or the plant decomposes and you make phosphorus fertilizer, you can get it out of biomass. That's one option. The other option is you can mine it out of rocks. But remember, because it doesn't have a gas phase, it's only in rocks, in water, or in living things, all of those are making their way to the ocean. Did I answer all your questions? Yes. Are there other questions? Yes?
You, are the macronutrients, are those all 6, or are they only...
I want to talk about the warm-up because this is something which is buried in your book and a lot of kids don't pull it out. I wanted to do this as our last final warm-up because everybody has to know this, and frankly, over the years I've noticed a lot of the kids don't get it out of the book, so I'm just going to give you like the shortcut. Remember that when Alessio's body is decomposing in the bushes, what happens when a decomposer gets a carbon compound? What do they give out? If Jose eats a plant, I get the sugar and I give out the CO2, which is a gas. So Alessio's body, decomposing in the bushes, would give off his carbon as gases, CO2. Hydrogen and oxygen also, mostly as gases. So of the 6, of your book's big 6, C, H, and O, they cannot be gathered from decomposition. They go up as a gas. However, N, P, and S, nitrogen, phosphorus, and sulfur, those tend to be available from the decomposition. Nitrogen as ammonium, phosphorus as phosphates, and sulfur as sulfates. So today's warm-up is probably news to most of you. And I'll give you a heads up that that is a critical fact. Carbon, hydrogen, and oxygen decompose to gas form. Nitrogen, phosphorus, and sulfur, they can still be cycled from decomposition.
And those 3 never have a gas form?
Coincidentally,
Nitrogen does.
sulfur does and nitrogen does.
Right. Phosphorus doesn't.
Phosphorus not. But that's not how they are decomposed. You'd have to, I think, light it on fire or something to get the sulfur out as a gas. I can't remember. And the nitrogen has to be decomposed by other bacteria before it'll actually go into gas form. Yes?
So if someone dies from being lit on fire with the sulfur?
I don't know. Don't quote me on that, man. This is on the web, and I hate to be wrong.
Wait, what does sulfur come out as?
Sulfates. Yeah.
Sorry, you said nitrogen, phosphorus, and sulfur can be cycled through. I missed the word that you said.
Decomposition.
Okay.
So there they are. Look, I even wrote it on the board for you now. CHO, these are released to the atmosphere in decomposition. But nitrogen, phosphorus, and sulfur, these stay in biotic cycle.
Oh, wow.
That's really cool. I should warn you, by the way, that apparently they know 6 and what school did you say? Seven Junior High. They teach you 6. I'm really sorry to scramble your eggs. Some people would give you like 4 that are critical, then 6 that are like used in large volume, then 30 that are used in small volume. So check out my periodic table of elements for biology. They have a big 4, followed by 7 macronutrients, and 1, 2, 3, 4, 5, 6, 7, 8, 9 micronutrients. It's kind of arbitrary. This is the warning I have to give you. If I look at every element inside Alessio's body, there's a little bit of gold and a little bit of uranium, but very little, just a few atoms. And there's a whole lot of hydrogen, carbon, nitrogen, oxygen, so we just rank them. The most common is probably hydrogen, the second most common is probably carbon, the third most common is probably oxygen. But this is the part where I have to warn you. You can cut that ranking off at 4 if you want, and those are the big 4. Or you can cut it off at number 5 and call it the big 5. Or you can call it off at number 6 and call it the big 6. There's nothing special about cutting it off at 6. Your book just said the big 6, and those are the first 6. But there is a 7th and an 8th and a 9th. It's just kind of, your book arbitrarily said 6 of them. So that's the only 6 that we've been talking about. Does that make sense to everybody? Like number 7 is still really important. It's just the 7th. Yeah.
Why is there gold in human?
Because you can't avoid getting a little of everything into a body.
But through what? Like the last time I touched a piece of gold?
Oh, you know, in your diet, radiation. There's just like little atoms of stuff in everything. You have a little of basically everything up there. If it exists on the planet at room temperature, there's probably a little bit in each human. If you count the total number of atoms in Alessio, we're talking, I don't know, man, thousands of trillions. So there's probably like one of the really rare ones in there. You would just call it swamp, I guess. Okay, kids. I am available to make you smarter if you ask me the right questions. How can I help you? I am at your disposal. Yes?
So the last part of number 18, what role does phosphorus play in the rest of the ecosystem and how does it get onto land? You probably just went over that, but I'm like, kind of.
Biosphere cycle.
ATP is the role it plays on land. And it gets onto land by biotic cycling and erosion or weather. So it comes out of rocks or it comes out of the biosphere. Did I answer your question? Next, yes?
How much time, or for number 7,
Yes.
how much time does each chemical spend in the cycle?
It's not like a specific number, but you should know that which ones are very fast and which ones are very slow. Once something gets into rock, it'll probably be in rock for
lithosphere slow.
a long time. Yep. And once something is in the biosphere, it just depends how long it takes before something rots or gets eaten. So that's basically a metabolic time frame. In the atmosphere, it's pretty immediate. You can put something into the atmosphere right away and take it out of the atmosphere right away. So things spend very little time in the atmosphere, medium amounts of time in water or metabolisms, and a very, very long time in rocks.
What about,
Because rocks live
what about
forever.
water?
Water-
I get food.
Yeah.
That's also fast like atmosphere, right?
It's probably closer to metabolic speed, actually. That's called water medium speed. Because your body is metabolism based on water, so they spend about similar amounts of time. Sorry, unless you had a question first, and then I'll get to you.
Yeah, sorry.
Maybe he's not ready. What is it?
Well, biosphere, would it ever be, like, so it's pretty much the same as the hydrosphere?
Probably. Yeah, yep. Yes.
What is the condensate in this?
Some amount of carbon leaves the biosphere. That's what we say has sunk. So when something is fixed or has been uptaken or assimilated, it's become a part of the biosphere. And when something drops out of the biosphere, like it's buried in a mudslide or gets turned into sand, we call that a sink. Like it's left the biosphere and is on its way to becoming rock now. So a carbon sink is any place where you take carbon out of the biosphere. Like the bottom of the swamp where the sediment will cover up the leftover lizard parks or something. That's a sink. Now the funny thing is, we have cool satellites and mathematicians and nerds and algorithms that can keep track of how much carbon is on the planet. So from outer space, we can figure out how many plants there are. So we can photograph the green and see how dense the green is and approximate how much carbon is in all the forests, for example. We can take all the biomass estimates of the ocean and figure out how much carbon is in the ocean. We know how much carbon has been added to the atmosphere, and we can measure that volume. The funny thing is, when you do a full carbon budget, there's a little bit of carbon which has been leaking out of the planet. That's called the missing carbon. We know it's sinking because it's not in biomass, but we just don't know what sink it is because we know how many swamps there are. And on average, we know how much carbon goes into a swamp. And there was a certain volume of carbon that we know was leaving the planet, but where the heck is it going? It's not in the biosphere, it's been sunk, but where the hell is it? And people figured out that inside the guts of fish, carbon sticks to calcium and they crap it out as sand. And that was a phenomenon that nobody had thought of before. So we realized that each fish, if you like mash up the fish poo, there's a little bit of sand in there. And then you do the math, and it's like there's a lot of fish, and they poop pretty often. So like 1 billion times 1 billion equals, that's a lot of carbon. And apparently the majority of our missing carbon, we now realize, is no longer missing. We know exactly where it's sinking. It's sinking to the bottom of the ocean as little microscopic bits of sand in poo. And girls, I've got a news flash. If you drink carbonated beverages, this happens inside your guts too. But girls, remember, you need your calcium. Because if you decide to get pregnant someday, you might have to grow a fetus, and they're going to take all your calcium away. So you can't afford to spare any calcium. Girls, do you know about this thing called osteoporosis? Where women develop brittle bones because they've used up all their calcium in childbirth? So apparently, girls, because you have to worry about your calcium budget, the fetus is going to use up a lot of your calcium. You got to keep it. You shouldn't be drinking carbonated beverages. It's the same thing that happens in the guts of the fish. The calcium in your diet is crapped out as sand. When you have a lot of carbonates in your stomach, like carbonation, like bubbles and fizzy water and soda, and I'm sorry to tell you, beer. So girls, the carbonated stuff is threatening your calcium supply. The same way it happens in fish guts, it happens in your gut.
So it's like the hard alcohol.
Yeah, exactly. So think of the hard alcohol or water, milk. Yeah.
Okay.
Is that your question?
Yes.
Can I answer your question?
Every time you call me, I forget. Okay, so the calcium cycle and the sulfur cycle, like in comparison, I already wrote down because the calcium cycle is slow, the sulfur cycle.
By now you already know this, and that's all you need to know about those two. One of them is slow, one of them is fast, because one of them has to wait for the rock thing.
Sulfur is gas.
Yes.
And did we go over like specifically sulfur?
Neither of those cycles specifically.
Okay.
Yes.
So does leakage fall into the category of like a carbon sink?
Yeah, leakage is sinkage.
And so inside the fish that's leakage?
Yes. They are taking it from biologically available carbonate ions. That carbonate could be used for life stuff, but instead they just go boop,
And it turns into sand.
it turns into sand, and when they crap it out, that's sand for sand for sand forever. It's just sand. So that'll become rocks, and that'll become erosion, limestone. Yeah.
Is the atmosphere included in carbon sink? When carbon is breathed out into the atmosphere, is that included?
I think so, because it specifically sinkage is leaving the biosphere. But remember that atmospheric carbon is just a breath away from being biotic. So that's not like long-term safe.
But it would technically be the same.
I think so. And I think that there might be some distinction between a long-term safe, which is lithospheric, and a short-term safe, which is temporarily in the atmosphere. If you understood that distinction, you understand why I'm not ready to answer
Yeah.
for sure, right? Yes.
Okay, so like short summary would be carbon leaves biosphere and goes into the lithosphere.
Yep. Very good. These are excellent questions. I'm really glad we're doing this. Keep going. We only have a couple minutes class. Let's go. If not, we're going to talk about my beard or something. So yes.
For the difference between the sulfur and calcium cycles, it's that calcium takes longer than how gas phase.
Yeah, that's right. Remember that things that depend on rock formation, if the only way you can move it back to land is by making it into rock on the bottom of the ocean, you're going to wait a while before it comes into play again. So yeah, exactly. Slower or faster. Yes.
When the carbon goes into a carbon sink, like that becomes rock, when it's eroded, does it come back into the biosphere? Or is it-
When it's eroded, you would say it's in the hydrosphere because it's in water now.
Okay.
And presumably, now that it's in the hydrosphere, if it's biologically useful, the first plant that gets a whack at the water will probably make it to the biosphere, right?
And how does it take that?
Fish get carbon, I believe. You mean to make it in their guts? It dissolves in water.
Oh, okay.
Yeah. Yes.
What does carbon sequestering mean?
To sequester something is to hide it. Like in Spanish, secuestrar is to kidnap. So carbon sequestration is to kidnap the carbon, like put it away somewhere. So the main methods of carbon sequestration that we're talking about on the planet today are probably turning it into concrete or burying it underground. Because it's sinking, right? To sequester it is to sink it somehow, take it out of the biosphere.
It says that whale poop
Yeah,
carbon sequesters.
that's right.
Okay.
Because when they poop, the stuff sinks, right? As sand. So it's all the same concept. To sequester is to sink it on purpose. Yes?
I think we learned these a few days ago, but I still
Good.
don't have them. That
Okay.
habitat physical engineers.
All the same thing.
Yeah.
Do you know what engineer species is? One who shapes the habitat for other species. That's the same term for all of them.
Like the beaver.
You're liable to do it.
And
So other than carbon being in the atmosphere heating up, the globe and stuff like that, what else? What other effect does it have?
A very serious problem, and everybody has to know this all year because it comes up in every single unit. And I forgot to tell you, I'm glad you asked the question. Look up. Oxides plus water equals acids. That's just a truism of chemistry. Any oxide plus water is probably going to give you an acid. The main oxides all create the main acids. So look, carbon dioxide mixes with the ocean to make carbonic acid. One of the deadliest things about our carbon cycle tweak, you guys know that we've been tweaking the carbon cycle. We talked about that, right? All of our extra carbon is heating up the planet, but it's heating up the planet a little bit slowly relative to our time frame. Over the next 600 years, it's going to get really hot really fast. But we don't look at it over 600 years. We look at it over like 36 years or something. So the global warming is a serious problem, but much faster, like overnight. Carbon mixes with water to make acid, and you add more carbon to the planet, you're adding more acid to the same size ocean. So the ocean is becoming really acidic. Oysters are going to stop growing. We've already seen their rate of growth make them no longer valuable to farm. You used to be able to start from a seedling oyster and sell it in whatever it is, 5 years. Now it takes like 15 years for them to grow that same market size. So it's become too expensive to be a viable market to farm oysters because the ocean's more acidic.
Why would the acid stop their growth?
Because the formation of their shell depends on a basic environment.
Okay.
Yes, Patrick.
You said that earlier, I think about 2 days ago, and when carbon is in the lithosphere, when it gets trapped in there, it becomes fossil fuels in a
Some amount. Yes.
Okay. And that's what fossil fuels are made of, correct?
Fossils. Yeah, stuff that used to be alive and got converted by heat and pressure. Remember that it can be squeezed out in a bubble. It can be returned to the biosphere by tunneling. It's like a really slim chance. It's a fluke in rock formation. It's like an error in the rock. So most fossils do not become fossil fuels.
Okay.
Yes.
I also know a predator effect. Is that when like a predator helps like someone at the species at the bottom of the food chain by eating their predator? Is that
Or their competitor.
So their competitor, not their.
I've got an explanation that answers your question, but it's like 7 vocab words strung together.
Yeah.
Protect diversity by limiting competitive exclusion. It's just a couple of words, right? But you keep the competitive exclusion from happening. You keep one competitor from kicking out the losers. You keep the big kid on the block from getting rid of all the little kids on the block.
So protect diversity by limiting.
Competitive exclusion. What that means is if one competitor is getting more and more common, they're getting ready to take over, that's going to be the majority of your diet because it's the most common food. So predators just eat whatever's most common, and that lets all the losers kind of get a break from the competition. Does that make sense? Yes.
Is the wolf effect a term you can use to describe other things that are similar that don't involve wolves at all?
I'm not aware of anything that has as much impact as wolves in Yellowstone.
Okay.
The wolf thing is kind of
Really exclusive.
a one-of-a-kind, because how would you describe that? It
I
changes
was
the
just wondering,
behavior.
something like that happened in the ocean might be called wolf effect still.
Probably not. I think we call it shark effect.
So it's not like a general term that you can apply.
To my knowledge, no. I've never heard that generalized beyond wolves in Yellowstone.